Hey guys and gals, hey guys and gals, what is good? What is good today? What is good today? How you doing? How are you doing? Thank you for dropping by. Thank you for hitting that play button. Let's go. Turn it up. You know I love that. You know I love that. When you guys show up, drop on by. Man, it's so awesome. So awesome. Great to have you guys and gals. Want to drop some more stuff in the chat here, and then we're gonna get to the stream. Doing mod stuff here. Appreciate you being here. How's your day going so far? Let's go. Okay, beautiful. I think that's it for that. I hope. I don't know. Let's do this. Let's do that. Let's do this. And let's do that. Let's go. All right. Quickly check to make sure we're good on the upside, the up end on Twitch. All right, beautiful. Turn it up. Open stories. Find streamers you can collaborate with here. The collab, blah, 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 blah. Blah, 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 blah. Blah, blah, blah. Oh, my guy EPN's on. Nice. Let's go. Stay here, though, guys and gals. I should, that's actually a good idea. Old school gamer. He's one of the OGs. Pretty super nice guy, I'm telling you. Super nice guy. That is, I'll drop that in chat. You have to be here for that. Again, check out the channel, but I want you to stick around as well. So stay tuned, stick around. You could, yeah. That's all I had. Let's do this. Yeah, that's right. I need to do shout outs. So we're good on the stream end, the live part. Also, if this is not live, hey, welcome. Let's go. I don't know what is with me today. All right, guys, I need to focus. I want to get shout outs, recent new follower as well. Let's go. That's so amazing. You guys showing up out of nowhere. I also want to thank you guys, gals, whoever you are, on Twitch. You guys are killing it with the views compared to YouTube. Thank you for that. Okay, YouTube needs to step up a little bit. The viewers, okay, not showing up. But you guys on Twitch, man, woo! Nice. It's awesome. Keep finding the content, whoever you are, wherever you are. It's great to have you. It truly is. I'm going to say it over and over and over again so you guys understand. It's amazing that you do that, showing up, watching the content. I love it. And then on top of it, subscribing too. I don't ask you guys to subscribe. You guys just hit that button. It's amazing. Amazing. Some motivational quotes in chat, I guess. Again, you got to be part of the live stream to see the wonderful quotes I like to drop in. Keep you motivated, guys and gals. Keep you motivated. And it's good for reading too. Because why not? Who wants an empty chat? I know I'm bad for spamming it, guys. Okay, but I like to get all the information out there done. Then I don't have to focus on it. I can just focus on the content. All right. Now the shout-outs part. Where are you? Shout-outs part. It's in this document. Let's see. Boom. Do that. All right, shout out. Shouty outies time, guys and gals. It's shouty outies time. Usually I have an intro for that, but that just means I have to look for stuff. All right, you guys are all amazing, every single one of you. Twitch, YouTube. Want to quickly, if I can, I'm going to shout you guys on YouTube. There's a lot of you guys on YouTube, okay? You guys are showing up to certain individuals, not everybody, but I'm going to shout you guys out. Let's begin here on Twitch. Nicole Trey 66, great to have you. Bart number 1, Jim Jam 1238, Kazzer 20, my man, let's go. Gavin 555, Kamikaze ML. I kind of go on a tangent with the kamikaze thing, but kamikaze, don't kamikaze yourself, bro. I love you, man, as the individual person that you are. It's great to have you. Thank you for showing up, being part of the channel. I hope all is going well, my guy. Right. Let's do this. Okay, I'm dropping the ball a little bit. Too many tabs going up, guys and gals. I got too many tabs open. I actually have a funny quote on that. Let's see if I can find it. My brain has too many tabs open. That's what it is. Too many tabs. Bringing up too many tabs. That uses memory, you know, guys. Memory! Let's see if I can find one more thing here. And I'm going to continue with the shout-outs. But I love to do this as well, of course. Thinking that it's going to be low volume. Yep. There we go. Turn it up. That's for I Ducky. Let's go. Hi, Ducky. I love the name. It's funny. I'm sorry if I call you I Ducky. Like, it's easier to say than Pipe Ducky. Let's go. Back to shout-outs. We're going to continue. Where is that? I have to scroll through it again because I ended up switching files. Ooh. Thank you in chat for being here. Let's go. We're going to get to it, guys. If you're on YouTube and watching this when it's not live, there will be like a timestamp that you can kind of skip to. Kind of the learning stuff. I'll do that for you guys and gals. If you're on Twitch, yeah, it's kind of not able to do that here. So, I guess you could kind of just guess skipping forward. But it's great to have you. I like to kind of chat with you guys a little bit, do shout outs, same common stuff I begin all my streams with. Again, if you want to get right to the content, find a timestamp, let's go. And then we'll be learning together. Turn it up, I love that. Continuing on, let's go, turning it up. Twitch fam, Wicked Stat. Con Papa's 9, how you doing, Con? Slow Motions, my guy, turn it up. And recent new subscriber, follower, I'm going to turn it up. Thank you so much. Amir Hassan, 23. Thank you so much. Namaste. Turn it up. And going off over to YouTube land, quickly show you guys out. Nap, Vision with a $sign. I love that. Peter N, Caesar Rojas, Tech Dave 99, my man. How you doing, brother? WX87, and the rest is too long to say, but welcome. Flawless Hack. Let's go. Salt of the Earth Ministry, blessed brother, and Aya, or that's the easiest way I can say that. Ayawi, that's it. Ayawi, turn it up. Let's go. Yerp. Let's go, guys. I think I'm done with this document. I don't know. We'll see. We'll just leave it up just in case. And we're just about there, guys and gals. Get back into this streaming groove again here. Trying to. Guys and gals, let's go. Thank you for your patience. It means so much. This is for you. Guys and gals, this is for you. And play. Yeah. That's my fam. My fam in the background shouting it out for you brothers and sisters supporting Johnny here, Whiskey Tango Shark Coding. Much love, guys, gals, you beautiful, intelligent people, because who else would I be talking to other than beautiful, intelligent people? Because this is coding. It's not for everybody. I have this kind of thing I say, I don't know what I usually say, but it's like, let's be real here. I'm going to just be real, okay? Not everybody's clicking the play button for my videos. Oh, it's learning? No way! I don't like learning! That's too hard! Sorry guys, that one's on a double loop. I don't know why. Yes. Okay. Now, just so we're clear here, you guys, I wasn't talking about you that are watching, okay? Because obviously you love learning, because you hit the play button, because you showed up, because you're part of the stream, or because you're a lurker and twerker, or because you're watching the content when it's not live. Amazing. Every single one of you, amazing. Truly are. All right, that is it. It's time. It's time, guys and gals. I think it's time to do some learning. Let's go. Again, appreciate the views, the views on the content. I've been putting it up there for you guys and gals to check out, and a bunch of you have been showing up, and it's great. Again, you guys showing up, following the series, watching the content, that keeps this going. All right. It's you guys and gals that keep this going. All right. I want to kind of mention something. All right. Just as a heads up, this is a course/lecture that we're doing. Okay. I'm trying to make it fun over here. I don't know. I try not to over-explain stuff, but I will explain it probably more profusely than I should. The end result is I want to make sure you guys and gals fully understand. Okay? That's the goal. All right? Over here, learning and trying to have some laughs too. Doing my best. It feels like a Monday though. Feels like a Monday, but it's not. All right, we are continuing with functions. Let's go. All right, guys, gals, this is a lecture course over here. So if you're looking for quick, short content, you've not found it. No, you have not found it. All right. But those of you that are looking for like lectures and classes, courses in regards to C++, it's great to have you. All right, that's enough of that. Time to learn. We talked about defining the function, the different parts of a function. Might have to kind of recap here a little bit, but I think we're getting right into creating a function. Okay. Now we're going to clean some stuff up here, some unnecessary information. This was a function we were working on last class. Yes, we're keeping that one. We're going to get rid of this one. And we're going to clean up this stuff here. Continuing today's lesson stream, continuing with functions. Functions are fun. They are so much fun. And then we should have one down here. Passing in parameters. Yes. Okay, I'm going to go like that. We don't really need that either. Okay, guys and gals, bear with me. I got to get the Minecraft cobwebs out of my brain and focus. All right, so let's start with, we're going to create a function, declaration, and the definition and the use of that function. Okay, remember the three main parts of a function: the intro, header part. Okay, our function prototype it's called. Then we create our definition, what defines our function. Again, now I have to kind of update this as well. Slow motions, I appreciate you. We're getting the recent follower in there today. Let's go. Thank you for the support. Continuing the definition of our function, where basically we just defining it. We were telling, hey, compiler, program, run whatever's inside this block of code here between the curly brackets. And then, of course, the last thing we do is the third step is calling our function. All right, let's start. Now, step one, you could either start with, it doesn't matter, you could do 2 first, then 1, or you could do 1 first, then 2. It doesn't really matter. We could start with 2 first. We're going to create an int function. I'll show you how you kind of do it. This might be a little bit faster. What are we calculating here? We're going to do an area, just a simple area function. Calculates the length and width. I don't know, it could be anything, length of a rectangle. It could be length of a square. Mind you, square is side squared, but it all works out the same. Multiplying a number to another number, it's all the same. Calculate area, we'll call it. And there we go. So that's the first step. So we're working on the step 2, okay, first. All right, doesn't matter. You could do step 1 first or step 2 first. It doesn't matter. Okay, let me show you a little quick trick. The reason I'm starting here is because we're going to put inside, this function is going to take in parameters, okay? Takes in, let's go, takes in 2 parameters, okay? We're going to put in 2 parameters. Let me show you, and you can do this, right? Because, of course, let's just call it a rectangle, right? A rectangle has a width and a rectangle has a length, right? 2 parameters. So int, we're just going to use int. There are other data types we could use, but this works, okay? It's a little more excessive than what we need in regards to range, but it's all good. Let's see. I'm just trying to think of changing the variable names, but I'm just going to write it like this. Length, width, doesn't really matter which one's first. Width, then length. Okay. We'll go width, then length, okay? Again, this is an int function. It's probably going to say static, I'll guarantee it. I knew it. Let's go. We only have one source file, so really it's static to this. So, I mean, it's not going to hurt. What is static, you might ask? I'll find a quick definition. Maybe function, maybe I'll put, or a static method. Okay, a static method or a static member function. Again, this is a function. It's not part of a class. Anytime, guys and gals, I'll repeat myself on a lot of the different theories and concepts. But if you hear member, just think function. A member really, member function. Is also called a method, okay? So if you hear method, just think function. It could also be called a member function. Really, a method or member function is basically a member that's part of a class, okay? We haven't done any classes yet, but don't let it confuse you or discourage you. Just a method is a function. Okay. Okay, a static method or a static member function is a function that belongs to a class but is not associated with any particular instance object of that class. We'll get into instances and objects in the future. Stay tuned. Man, guys, please bear with me today. All right, instead, it belongs to the class itself. Okay, what is the static? I just want to know. Declared with the static keyword, that's all we really want to know. We don't need to know this whole other story. You declare a static method by placing the static keyword before its return type. Of course, our return type is int. So, you hear return type, just think return. Okay? That's all it means, guys. When defining the method outside the class, you typically don't repeat the static keyword. Maybe I'm just going to, what does static mean? Just to give you a better, because I don't want to give you a brutalized definition. What does static mean? C++. Okay, obviously not in motion sort of thing, right? So we have global or namespace scope. When static is applied to a global variable or a function declared at the file level outside any class or function, it gives that variable or function internal linkage. Okay, there you go. I wanted to find a definition so that I'm using the proper theory or wordage, okay? This means the variable or function is only visible and accessible within the same translation unit. So when you hear translation unit, just think source file, or right? This is a translation unit, this whole file. Okay? Translation unit. Where it is defined. Okay, again, so this means that the variable or function is only visible to this source file. Okay, and accessible with the same translation unit where it is defined. It cannot be accessed from other .cpp files. Of course, we don't have another one created. We would create one, but a lot of times if you create a source.cpp, and I don't mean to go on a tangent, really it would just have this definition inside anyways. So, but you can have like other source files, other CPP files. You can have more than one, guys. Okay. We'll just keep it kind of simple for now. All right, guys, here just kind of going step by step, gradually, and let's just keep it simple. All right, basic for now. We'll work our ways up there. Okay, so basically that's what it means. This function is only good within this main.cpp, and that's it. If I created another source file, it just won't be seen, right? I won't be able to access it. It's kind of like a private public thing, if you will. If you use it for variables, it also ensures static storage duration, meaning the variable is allocated when the program starts and deallocated when it ends, retaining its value throughout the program's execution. Okay, in a global sense, yeah. All right, we'll get into that. That's actually a good question, to be honest. There's some decent examples there too as well. I want to put this into here so I could save that for the future. For the future. All right, I need a coffee drink. All right, there you guys have it. Okay, that's all it means. Okay, it could only be seen inside this. That's all it means. All right, so it's okay to put the static because we don't have anything else. So it's no big deal, really. All right, so we're going to return basically area is length times width. Let's continue. Trying to get the wheels spinning here a little bit quicker, guys and gals. Okay, so here's the reason why I started with it. Can't even speak today either. Here's the reason why I started with this down here. It doesn't really matter, but I could go like this. I'm going to go like this. I believe the static is part of the header portion. And paste. Boom. And get rid of that. And that. Okay, that's so much quicker, right? So, again, the reason I did that is I'm going to create the definition first. Then all I do is copy the method itself without the curly brackets, of course. Just paste it up here. End your statement or your function prototype, because that's what this is. A function prototype. All right. And then all you have to do is just delete your variables, and that's it. And I'm pretty certain, just going off the top of my head, the static is, you declare the static in the header part, okay, or our intro part, and the definition is you could take it out of your definition part. All right, now we've got that done. We've created a function. We got our prototype done. We've got our definition done. It's pretty straightforward. Now, again, all the magic happens inside int main. Let's continue. Let's write some code. So first, we're going to need to obviously... So whatever you type inside the int main, your variables that you create are kind of separate from... This is the third part, right? Now you got to create all your code. You could have the user enter in values if you want to There's two ways of doing this, maybe even three. We could create our variables. I don't really like reusing the same name. That's the thing, right? So I'm gonna shorten. How do I do this? These are all public still, so length. Let's just use. The hardest part about coding is really the variables, coming up with variable names. Okay, so I could go like this. I like to keep my variable names different. Some people, you'll see that the variables are the same, and it's okay to do that. There's kind of, I don't know how to explain it. They're still separate of each other. They're not exactly the same variable. So it doesn't really matter in code if they're the same or like matching, or if you make them different. Okay, as you can see, they're different, right? I'm just gonna end this. I have to start with width first, and then comma, and then fix this to width. We're just gonna pretend it's a rectangle. Okay, there's our variables. So I've obviously declared them, created a variable name. I've also initialized them. They're right now initialized to 0. So there's a couple of ways to do this. We could hard code them. So what that means is, I don't know, some random value. Could be whatever it is. Let's go like this, and let's say the width is, I don't know, 11. Okay, which makes sense. All right, so this is hard coding. Okay, so they can be changed down the code, but you would actually have to physically change them. Let's say the value down the code changed to 13, right? You can do this in code. So there's that. And the other thing we could do is, I've showed you, I believe I've done this already with you guys and gals. I hope so. I'm going to get rid of this, and I'll show you the other way. And that's to get the user involved, right? So let's create code where a user, because that's kind of essentially what you do anyways. When you're creating programs, you want the user to be able to kind of participate in the program and be able to input data of sorts, right? So instead of hard coding, right, because we could easily hard code this and make it simpler, but let's get the user kind of involved. So I'm going to go results. I got to make sure I don't write return. Rectangle, of course, that's got to be 0. We need to return something to the console. We need a variable for that, right? So we're going to do the calculation with using the function, but we also we need a variable so that we could actually print that to the console or the program we're creating. Okay, back to the user. All right, so let's begin here. Standard cout. User prompts, I like to call it user prompting. Okay. And I don't know why there's a backslash, but anyways, we're following the course outline a little bit. How wide is your rectangle? Could be anything, the area of anything, right, guys? Okay, that's obviously a question. And then now we gotta actually put that information into the system, note your direction of your overloaded operators. They are, I don't know why I would go over the definition of them again, but I'll bring it up anyways. Okay, stay, don't move. Okay, right here, CN, stream extraction operators. Note the direction, okay? All right, let's continue. So that's to put information, user input, into our variable. That's what we're doing here, all right? So we're gonna need our width variable. That's where it's gonna be stored. I'm just gonna copy this, being a little bit lazy, but make sure you immediately update your code here, because it's easy to have the wrong variable. All right, guys? What is the length, right? You could turn this into an area of a backyard, area of, it could be an area of anything. Quick little program somebody could just bring up. Boom, boom. Maybe they do grass or sod, or maybe they're doing a fence. Who knows, right? They could bring up the program, put in their data after they've done their physical measurements, and then boom. I mean, it's a simple calculator, really, but all right. There we go. So now this is where our other variable comes in. Okay, you need this so that we can return back to the console. You need that variable. It doesn't work if you just call this method. Okay, let me show you. Okay, so I'm going to put in our variables. I'm just deleting that. We're just replacing. These are our parameters. Now we're going to put in our arguments. This is where we put in our arguments. Okay, you'll hear the words parameters, arguments said in the same meaning or same sentence. These are our parameters. And we're going to put in our arguments. Our arguments are going to be this variable and this variable, right? The user inputted variables. End with a semicolon. Okay, so the reason this doesn't work, guys, right? Look at our function here. Our function, all it does is say return, and it returns whatever the calculation turns out to be. Okay, that's all it does. If you notice, there's no, like, void is the only one. I'm just going to use example for now, okay? Okay, the void is the only one that you use cout, right? This is how we return information to the console, right? By using standard cout. Void has no return, right? Right, no return. But you can return values. You can return numbers. You can return whatever you want. You can. I could actually put in int value and just return value to back to the user. I could easily do that, right? If I wanted to. Simple little void. There's no calculations or anything being done, right? That's the difference. The int function is used for, you know, they're kind of like they're helper functions, really, in that sense. And if you want to print whatever value back to the user, you use a void function. And that's where you could actually take this helper function and put it inside here. Okay, so we'll do that in the future, but let's just kind of learn, right? Thank you for being here and watching, guys and gals, and bearing with me today. Just kind of getting back into the groove. I have been pretty busy. Keeping busy, still grinding code, still doing different things, working on my project. I'm really close right now. But I kind of took a couple of days off from working on my project and been spending time just kind of elevating my knowledge in regards to coding. All right, so continuing, right? So look at all it has is a return. So all that happens here is we're getting width times length, and it's going to return that value, but it's not going to actually return it to the console. Okay, this is where people might get confused, and that's why I'm trying to explain this part. Right? So we need that extra variable to store it. So really what it's doing when we call this function, right? We're actually calling it. Right here's where we're calling it. Okay, it's going to take in those user values, so whatever number gets stored into this variable, whatever number gets stored into this variable, it'll jump to our method, or function I mean. It'll do the calculation, but it'll hold on to that number. It's not really stored. It's there in the function, but it's not being printed, if that makes sense. I hope so. Right? It's kind of there, right? It's not even being stored into anything, come to think of it. But really, in reality, the process happens kind of during runtime anyways. So when all the magic is running and the program's running, that's when the calculation's done. So while it's live and running, it'll take the calculation and return it. Okay, but we have to store it somewhere, right? We need to, because it's just floating, it's in limbo. You can think of it as a right-hand side, right? You can think of it like a right-hand side value. In that sense. Okay? Now what I mean is, for example, okay, 67 is just a number, right? It's just kind of there floating in limbo. It's not being held anywhere. I mean, we'll look at this, but what is actually happening is this is the right-hand side, right? The right-hand side needs to go somewhere, right? So it gets stored into the variable. It's the variable that's something I should have actually brought up when I was actually going through all this. Let me give you the definition here. I feel like maybe I'm dropping the ball a little bit. I don't want to drop the ball on you guys here. I want you to understand. Okay, I'm looking for something where, yeah, did you know the variable itself? That's what I'm looking for. I've actually numbered my program here so that I have an idea where things are. Okay, here we go. This is what I want to share. And I apologize, I haven't shared it yet. All right, did you know the variable itself holds or stores a number value into memory? RAM being your random access memory, which is your temporary memory. Again, like I've explained in the past, if you've been watching the series, guys and gals, think of your RAM or your temporary memory as like the library for the CPU. It kind of accesses the library on the fly. Again, when the program ends and gets closed, well, the library gets closed and emptied, actually. But that's not what happens to a library in real life. All the books are still there, but in regards to a computer or a laptop or whatever, when it gets shut down, the RAM gets cleared. It's emptied. Okay? That's why it's temporary. Values can be stored either in a variable or variable name. Okay? So I say that like this is just a single variable, or we can have a variable name. Right? Right-hand side gets stored into left-hand side. Whoops. Click the right one here. Okay. Variables such as memory X. I love math. Math is a dub, and so on. Obviously, I was doing math at the time. Int X. That's just a single variable, storing or holding garbage or random data, which is true what I'm kind of explaining here. You'll see me use these curly brackets. Curly brackets, once you see code and see enough line code, you'll know what, because it's like the same symbol is being used, but it's in a different context. It's being utilized in a different sense. Okay? Here, the curly brackets here, this isn't a block of code. It's actually initializing y to 0. That's what it's doing. And that's what I'm doing right here. Now, I'm not sure, like I'm using, I think it's 17 on this right now. No, 20. I don't know why I'm using 20, but whatever. I'm trying to be current, I guess. I don't know. But it really doesn't matter. For learning intensive purposes, it's good enough. So whichever standard, I don't know, 14, if maybe it was 14 I was using in the past 4 years ago. If you didn't do this, if you just did that and you didn't initialize, because all variables need to be initialized, okay? All right, so here all I'm doing, I know I'm kind of going on off topic a little bit, but we're still kind of on topic, and we'll get back to continuing with this function. All right, guys. Let's learn all the important things. Okay, this would be up here actually. All right, you always have it above your code, right? So that it can be seen, right? Code is run line by line. Okay, so these variables here, if we're using standard 14, imagine they updated, I don't know, like now it seems that these still have the value of 0. Let me just do something here. Let's run this. I'm going to see. Okay. I'm just curious. Okay. If I highlight over this. Oh, okay. Negative, negative, negative. Oh, there we go. Finally. I don't know why before. See, that's garbage, guys. See? I'm actually past. So I put a, what do they call these? There's a name for them. Right now I'm running, I'm going to stop this. I'm running the debugger. And I put this stop, if you will, kind of after the code. I meant to put it at the code. So let me run it here. Okay, and then we'll step over it. Okay, it'll see garbage. Garbage, garbage. It actually jumped. Even though I put it here, now you can see how the code is running. It goes line by line. It just went boom. It went bang right to the standard CO. It didn't stop here. It literally took in the information and jumped forward. That's what happened. Okay, even though I clicked here, I thought I clicked down here for a second, but I actually clicked up here. Okay, so but there you go. Okay, garbage, garbage, garbage. That's what that is. Okay, I'm going to stop this. Now let's initialize. Okay. Now I could do it two ways. I could go like that, guys and gals. It's whatever you decide. Okay. You can initialize. 0 is kind of the minimum, right? It's all the same thing. I just like to do the curly bracket thing because, well, it's less typing and it's quick and it does the same thing. So I'm just going to build it. Okay. And I got my stop here. There's a name for it. I really don't care. I know what it does. Okay. So I'm going to run it. So check it out. Okay. We haven't stepped into it yet. Okay. Remember how the program jumped before? I don't know why it jumped right here before. So let's step over. All right. So where are we now? We're here on this line. So these should be 0 now. See? 0, 0. This one's going to be garbage because we haven't stepped into it yet. We're just before it. So we have to step over it or through it. Step over. Boom. So now we're down here. You can see where the arrow jumps to. And let's look at our value. There we go, 0. Okay, so now that's what's happening, right? When you run your program. The variable itself is the container. It has a memory address / memory location. And it's holding the number 0. You can think of the number 0 as like a die. Okay, let's say you have a singular die, like dice, right? And the variable is a container or a shoebox. And on that die is the number 0. If you throw that die into the box, that's essentially what you have. You just have a random variable inside your container. I could shake the shoebox, I could shake the container, the dice or whatever's going to be moving around. But really, it doesn't go anywhere. It's still at its location. But that's just to give you an idea, the concept of what's happening. Okay, so to continue, I don't know. It's odd. Before it was almost like it was initialized before. Somehow in the code behind, but I was assuming that they kind of updated it so that you didn't have garbage. But again, the main point is, guys and gals, you have to initialize your variables to at least 0 to something. Otherwise, you're just going to have, and really what the garbage is kind of whatever is at the memory location at the time, right? The memory location in RAM has an address, right? Whatever's at that address could be anything. And what I showed you there was the anything, right? A bunch of random numbers that were negative, actually. Okay, but again, they're ints, so it's just a random whatever in that int range, right? So if I bring up this, if I bring this up, right, int has this range, right? And it could be negative as well. Again, it could be just anything, really. Whatever is there at that location in memory. Okay, in C++, null is defined as 0. Null or 0 is an integer. Float p equals null. You could do that. Don't worry about these asterisks right now. We'll get into that in the future. We'll talk about that in the future. That's all memory-based stuff. Did you know hard coding a value to a variable, for example, int x equals 45, right? So this is a literal constant, right? This becomes a literal symbolic constant. Just kind of pulling that out of my brain there. Note that you only need to declare a variable once within your line code, right? So declare means what data type you're using. Some food for thought on larger applications. If you had the variable x used elsewhere throughout your program, you would only have to change it once, and it would update the new value for every instance of x, unless of course you had decided to reinitialize its value somewhere down your code. Okay, so temporary values, what happens under the hood? Int x, say for example, int x equals 3 times 5. We're just hard coding it with two values, two whole numbers, and multiplying it, right? This is still right hand side stuff. It'll get calculated and stored into x, right? Again, so the number 15 will be thrown into the shoebox or container, okay? When the expression 3 times 5 is evaluated, the value 15 is stored in memory as a temporary value. The temporary value is then stored in the x variable, okay, right? We can change this value down code, but currently it's 15. Then the temporary value is discarded once it goes out of scope. That's why I have this end of program out of scope thing right here, okay? As soon as we hit the curly brackets, now we're talking about stack memory right now. The variables I'm creating here are on the stack. It's kind of pre-runtime stored variables into memory, okay? Stored, again, 0 would be stored into this variable. It's on the stack. We're storing on the stack. I'm also going to talk about these a little bit so you get familiar with kind of the verbiage or the coding lingo, okay? Word of the day or words of the day on the stack, okay? This is in reference to memory, okay? Just as a heads up. That's what it means. Okay, continuing. So here we got a function, right? Kind of same thing that we're doing. This is basically would be the function we would create for a square, right? We could use the same one for a rectangle. We could. Like we could put in values for a square into a rectangular formula. It doesn't really matter. We're just calculating, we're multiplying a variable times another variable, right? It doesn't really matter. Mathematically, it doesn't matter. Okay? But you could have a separate individual function just for a square. You could. All right, so similar happens even with a function when a value is passed as an argument. Okay? Right? These are our parameters, and we're going to pass inside our code into main. We're going to pass in our argument, right? The function calculates and stores the result as a temporary value. The temporary value is copied, assigned to whichever variable is used in the int main body. Okay, right? That's kind of a key word right there, right? We're talking about stack memory. We haven't done anything fancy in code yet, using any special symbols or syntax, which we will in the near future. If I could just get the Minecraft cobwebs out of my head today, that would be great. So the temporary value is no longer needed, so the system discards it. Right? So the memory gets cleared up, essentially, guys. Okay? And then left-hand, right-hand side values. That's kind of what we're getting into now. Right? That's what started all this. Okay? So this here, that's what I was saying. Think of it like a right-hand side value. It's kind of just a value that's floating in limbo. It's not being held anywhere. It's just a floating in limbo in-memory value. That value has to be held somewhere, right? That's what the variable does. Okay? So when it returns, when the code is running during runtime, when the program's running during runtime, it'll do this calculation live during runtime. It's not being done while it's sitting idle or statically, right? Obviously, all this magic happens during runtime. Okay, so when it gets to this function, it does the calculation, right? It does that calculation right here, but that value has to go somewhere. Okay, I know that was a little bit, like, I don't think it was too long to explain, but I wanted to kind of just be clear, right? Be clear and concise into what's happening under the hood so you guys and gals understand, right? So with an int function, we need to take that return value and store it somewhere, right? Hence why I created this int result. Okay, so check this out. Control V. If I actually ran this, it would give me errors, right? Once it got here. Actually, it wouldn't be any errors. I apologize for saying that. This will run fine, right? But that value here is just going to be sitting in limbo, right? So if I run it, let's say I put how wide, I'm going to go 11 and 23, okay? Nothing's returned, right? And so you'll run the program and you'll say to yourself, well, what happened? Why isn't it running? Where did it go? Oh, the humanity! Usually I go into my little rant of you running around and with your arms flailing in the air, screaming, ah, and tripping over your shoelaces, even though you're not wearing shoes, and all those sort of things, and on and on and on, and you fall on your face, and all those sort of things. I don't know, I just like doing that. But anyways, right? So that's what's happened, guys, right? So that you can understand, with the return type, we have to, yes, we're returning a calculation. There's going to be a value, but we need to store that value again, right? We need to store it somewhere, right? So this is how we do it. There we go. So right-hand side, this is the right-hand side, the limbo value, right? The value that's in limbo here, right, gets put into the resultant. All right, let's drop the yays, okay? And that's the reason for the extra variable, okay? I know that may have been a lot, may have been long, but I'll guarantee you guys understand. Okay, so now let's return that value to the console. So I could put anything, right? I'm the creator. You're the creator, right? You're writing the programs. You could write whatever you want. Once again, you guys, gals, once you get the syntax and the semantics down and the theory down and the understanding, and get used to how syntax is written and how each statement is written, once you get familiar with that, then you can go, man, I could write anything I want. And that's when I usually say the world is your oyster at this point. You could just put anything. But we'll just put something simple like, I don't know, area of your rectangle, right? We'll just say this is, it could be anything, area of your shape, right? It could be anything, area of the yard, area of, just depends on what program you're making, right? But we'll just say rectangle for now. I always like to put a colon and a space. This is all the syntax, guys. Standard, colon, cout, right? These are all operators, okay? There's our string literal, another set of operators. Now let's return our variable. Now our variable, this new variable is holding that calculated value in memory, somewhere in memory. And then if we want, we could either just numerous ways we could do this. I could end it with a semicolon there. I could go standard. I don't know why I do that lately. Standard cout, standard end line. I could type it like that. Or I could take this. Maybe I don't want all that extra writing. I could go here, put it there instead. Get rid of that. However you want to end your lines, always remember, end it with a semicolon. Now if we run this, I'm going to build it. Control-Shift-B, Control-Shift-S, or Control-S. Nope. Control-Shift-S. You'll see whenever you look at this side, your main here, if I type here, if I go like this, you can see how an asterisk popped up here. That means it's dirty. And what dirty means, it doesn't mean that it's likes, weird things or likes being non-clean. All it means is it hasn't been saved. Okay, so I'm just gonna click the top, Control-Shift-S, gone. Okay, so all it means is that you have to save it, right? So if you're sure if you haven't saved it, just have a look up here. All right, let's build. Let's run. Control F5. Boom. All right. I can resize this if I want. Why not? 11, 23, and boom. There we go. I should have maybe put in another enter. And let's drop the A's. We could actually fix this up a little bit better. Okay. What are your units, right? We actually don't know our units, but I could end with something like, I don't know, feet squared or something, right? I don't know what the units could be, anything, right? Or meters, could be meters squared, right? And then if I wanted another enter, right? If I wanted to keep some space in between, again, I could go like this as many times as I want. This doesn't reflect the output of your console. Okay. All right. So if I ran it, you wouldn't see all those enters. That's not how it works. Okay. I could put because this is a string literal, I could use the escape operator in a new line. So that'll work. It's right there. A lot of times I'll do that too if because this is kind of extra redundant. For me, if you have a variable, then you have to have something like how do I explain this? Let me just go undo. I think this will be the easiest way to explain it. Is everything fine? No. Okay. So you can see how I have a standard end line here after my string literal. Okay. This is kind of redundant. I don't know if redundant is the correct word. For myself, I like to take advantage of a string literal by just going like this. There's no sense putting standard end line behind all that, right? Because you could simply just put a new line right there. Okay? That's my tip. If you didn't have that, the string literal, then you would obviously have to do this so that you got that enter. Okay? Now Let's go undo. And then I'm just going to get rid of that. That would create a double enter if I left it like that. I could still put a double enter if I wanted. Just like that. Except, of course, I'm putting it in the wrong spot. I don't want it there. I've got a double enter right here. I don't need all those extra enters. That's kind of why I have this one. But let's say I wanted a double enter in front. There we go. I could put it there. Take advantage of your string literals. There's no sense writing standard end line when you could just take full advantage of your string literals and go with the escape operator n, right? Okay, boom, boom. There we go. I created some separation between the user entered values. And there we go. Let's go. That is basically a function, guys, right? So when you hear function, you're creating a function that's, well, a function, when you hear the word function, we're not working on classes. Just think of that, right? We're in our source code, our main CPP file, and yeah, you could create functions within that. Again, you have to give the compiler a heads up about what the function is, the type, and all those sort of things. You have to also tell it that it takes in two int values, or two int parameters, if you will. And then you do your definition, right? You could do this first if you want. It's fine. And then you could just a matter of copying that and going back down here, go Control V, get rid of the semicolon, enter, hit your double colons, and then type in your variables, right? However you want to do it. So at this point, I could actually do one for square if I wanted to. Again, I've duplicated this, so this would be a problem, right? Because now I've gotten duplicating code, and you don't want that. Okay. All right. That is a function in a nutshell. All right, let's continue with the course outline. Again, it's great to have you guys and gals. Let's go. All right, don't need to. I kind of already explained everything. I think we're good on that. Hopefully you guys are good. Get rid of this. I don't need that really. There we go. That was kind of the key explanation, was that right there too, right? Maybe a lot of people might not know why you need that extra variable, right? And that's why, because you need to store that calculation somewhere, right? And in order to be able to see it in the console, that you have to do the same, right? Okay, also note that the parameter names in the prototype are length and width, but the parameter names in the definition are right. That's why I was talking about the different names, right? They can be the same, right? I could have used width up here. I don't like that myself, right? Just think of this as kind of its own individual, right? It's its own person. Right? And then when you're creating new variables, you want those new variables to be a different name. They have to kind of mean the same thing, but essentially you're creating two width variables is what you're doing. I don't like them being the same name. I just don't. Okay? It can get confusing to see that. A lot of people might even stop learning coding because that can be very confusing. I've seen code like that, and I've actually had to decipher and try to read their code and go, okay, this variable is this, and this variable is that. And when you're working with classes, it's even more of a brain twister. I got through it. I figured it out. But it was definitely a good lesson on, again, I don't recommend using the same variable names. Negatory. Again, we're in the main here. So create new variables. Okay, it's separate. It's separate from this. This is outside our main, right? This is outside. Right here's the end of main, right? That's the end of main. This is out of scope. Okay, as soon as it gets to this curly bracket, any values that were stored they're just cleared. Bye-bye. Stack memory, okay? Okay, as discussed, the names in the prototype are not used. They are there as information to the programmer. It is good programming practice to match the prototype parameter names to the implementation parameter names. I didn't mean to read that. I don't want to confuse you guys. The arguments are passed into the function in the order in which the parameters are declared and defined, but no matching of the names occurs. Had you passed in width of yard followed by length of yard, the find area function would have used the value in width of yard for length and length of yard for width. The body of the function is always enclosed in braces, even when it consists of only one statement, as in this case. And I believe that's what they're talking about right there. All right, let's just carry forward. I use different variable names and such, but you get the idea. I'm just trying to give you some examples here, that's all. Execution of functions. When you call a function, execution begins with the first statement after the opening brace. Branching can be accomplished by using the if statement. The if and other related statements will be discussed later in the area of more on program flow. Functions can also call other functions. Yeah, recursion maybe. Yeah, it is recursion. Yeah, that's what I thought. Yeah, that can mess with the brain a bit, but recursion is fun. I did a little program on recursion. Worked great actually. Okay, I'll share that with you guys actually in the future when we get there. Okay, stay tuned, keep watching. It's great to have you. I appreciate your patience and understanding. I'm going to have kind of good days teaching and kind of foggy brain days teaching. I don't mean to have them, guys. It just happens. When a function is done executing, control is returned to the calling function. When the main function finishes, control is returned to the operating system. Okay, there you go. A little more theory for you. A variable has scope. So here we are determining variable scope. Right? This is the key part, right? When I always bring up the word stack, and then we got this out of scope topic, and then we got LIFO. LIFO stands last in, first out. The concept with LIFO is stack memory. So think of a stack of books, okay, like a library. Let's say you grabbed a 10 stack of books, okay? The last one in is going to be the one on top, right? Which makes sense. So you're going to grab the first book off the top of the pile. That's going to be the first one out. That's what LIFO means, okay? Deallocation of memory off the stack. So it kind of works backwards, right? So the one on the bottom, once we get to the curly brackets, the very book on the bottom is the last one to be deleted. okay, when the program ends, okay? That's what LIFO means. All right? We'll talk about that again. We don't need to go in too much detail, but that's the gist of it. Right? The stack of books analogy is the best analogy for understanding stack memory. All right. Okay, so any variables that we create here, these are stack variables, okay? Just as a kind of another heads up. Okay, a variable has scope. So whenever we write curly brackets, I could actually take all this calculation here. I could actually declare them first. I could take this, I could go like this, and I could actually create another set of curly brackets, guys. Crazy. Curly brackets inside curly brackets. Now I don't want to lose what I have, but here we have basically an empty scope. Okay? Essentially. And you could do this, right? So once we get to the end of this curly bracket, we're out of scope. Okay? Out of scope means we're out of scope. And yeah, then you can't brush your teeth, right? That's terrible. We don't want that. Go out and get some Crest. Do you brush your teeth with scope? Oh, right, you gurgle with scope. I forgot. My bad, guys. I know that was cheesy, but it was fun. Hopefully you got a chuckle. So I cut this part out that we did, and I put it inside of its own scope. So as a matter of fact, normally without these, as soon as it gets to this curly bracket, it goes out of scope. But what's going to happen is they're going to actually go out of scope at this curly bracket. Okay? And you can actually make variables go out of scope just by adding your own empty scopes, brackets. Okay, this will still run. Check it out. We're declaring our variables ahead of time so it could actually be seen within this scope because they're above. These variables are above, right? So it could be read in. It's seen. It's visible. All right? It's visible. We'll use a different value, I guess, this time. There we go. And it ran just great. Just fine. No change. The only thing different is what's happening under the hood. Our variables, all the values that were in our containers were removed at the end of this scope here. I brought that up just so you could understand scope, right? And what it means when somebody talks about scope. Okay, where am I here? There's too many tabs open, guys. Okay. A variable has scope, all right? These are variables. Okay, that's a variable, this is a variable, that's a variable. Which determines how long it is available to your program and where it can be accessed, right? If it gets deleted or removed, obviously you can't access that value anymore because it's gone, right, guys? When something goes out of scope, that's it, it's done. I can't access the information anymore. If I try to print again out here, we're going to have issues, right? Because now this is outside of the scope. This is a scope. If I build it, I don't even want to because it's just not going to see it. This is below the scope, right? If I build it, is it going to error? No. Let's just try. I'm curious. Whoops, that's a little bit much. Well, it did print it. Okay, wild sauce. All right, let's check it out. I'm going to go here. It should have been out of scope. Oh. Okay, all right, we need to step over. Okay, I entered our information. We're in here right now. There's the value. In memory, it actually set the calculation process already because we're actually past the method, right? The result is holding the value 276. That's holding 276. This is holding 276. You're breaking my mind. I know 100% guaranteed as soon as it gets here, it goes out of scope. I just made the assumption as soon as it got outside these curly brackets, that's it. It would not see it there. Okay, let's go here. And it's showing the 276, so. All right. Interesting. I'm just trying to think of this a little bit deeper. I mean, this is still down the code. Variables go out of scope. Guaranteed 100% at this point. Because this is the actual end. That's wild. All right. Okay, I'm going to get rid of that. Oof. Well, at least now you know. Okay, variables declared within a block are scoped to that block, right? So that's what this is, a block. Oh, right. That's what it is. I just realized. Man, I had a brain fart. Okay, so check this out. Now, I think this is it. This is why. Just clued in. Okay, let me explain. These variables are now in a global sense. Okay? Because they're above this scope. Okay, I'm going to try to explain this. The reason this was able to print here, I just totally figured it out. It took me a second. I didn't waste a whole 8 hours of my employer's income trying to figure out a problem. It took me, a minute, 2 minutes to figure out what's up. Just by reading that one statement. Variables declared within a block are scoped to that block. That's the key. That's the key thing right there. These are, I know I wrote local variables to the int main. This local global thing could get a little confusing. These are definitely global. If I create a variable up here, these are definitely global, 100%. Okay? But we're inside the int main here, right? So I've created a new scope just by adding these two curly brackets, okay? And it printed it out here. It's seen the value here. It's kind of a seeing thing. Can it see it? Right? Look at this. If I go jump over this, here's my variable right here. This variable is right here. So that means it can be seen outside the scope. Does that make sense, guys? So this is its own block. Think of this code as underneath a blanket. Okay? It's hidden. All of this is hidden. It can see, because this scope is below these variables, it can see it. It can see what is above it, no problem. I hope this is the analogy, okay? I'm trying to help you understand the under the hood stuff a little bit. Okay, it can kind of rack your brain a little bit. So, but this variable here can be seen still right here. You can see it. I can still see it. It's, even though it's below this scope, it can still see it right here. Okay, but if I take this, if I cut it, so now I just cut them out. Now I just put them inside. So I'm gonna go like this. This is gonna help you make sense of it. Man, I really had a brain tickle there. Okay, there we go. So now what I've done is I've made these variables local to the empty scope. Okay. They're local to the, see that? Look, immediately the program can't see it. I should have clued in. I should have clued in right at that moment. Like, my variable changed color here. You can see that. Immediately it changed color. That's because, you know, in my mind I was thinking, well, it should print. It shouldn't see it. But it still could see it because the variable was above the scope, right? It could literally jump right over. If I bring this back, right? See, now it's back to the normal color it should be. It can literally jump right over and see it. Okay? You could jump over a blanket, right? You can still see it. Okay? As soon as I put that variable under the blanket, now it's hidden. It's in its own scope. That makes sense? I hope it does. I don't know how to explain these things. Kind of trying to understand what happens under the hood can be a little bit mind baffling, but you kind of have to work through it, right? And there you go. See, look, can't be seen. Okay, now it won't print. So if I build it, that's why I was like, this is what I was expecting right here. I wanted to see this. I'm kind of glad these things happen to me so that you guys and gals can see, right? And I get to explain it because I'm like, oh my goodness, oh no, right? At first, right? But then there we go. I read that statement. Oh, that's so key right there. I'm going to put that in quotes because that's key. Okay, so I'm going to go like this. It's going to be part of our new notes for today. Okay. Okay. All right, well, I am kind of inside a multi-line, so I'm just going to paste it. Okay, there we go. This is good information right here. I don't know why. I don't like copying. It changes the brackets. Okay. I'm just going to go maybe right here. And then go like this just to clean it up. Okay, there we go. Variables declared within a block, right? A block of code is what they mean, right? Curly brackets is a block of code. Variables declared within a block are scoped to that block. They can be accessed only within that block's braces and go out of existence when that block ends. Okay? That's part of the out of scope litho stuff. Alright? Global variables have global scope and are available anywhere within your program. Okay? Guys, this is kind of key to understand. All right, that's why I put these little notes, right? If I create a variable here, I don't know. Okay, you can actually see it has a different color as well, which is good because it has that different color. Okay. Goodness gracious, Sally on Sundays. What is up? Okay. Man. Feels like a Monday, but it's not, guys. Okay. So it has a different color, which automatically tells me it's a global variable, right? I can actually access that. I should be able to see it outside this scope. I might even be able to see it inside the scope. So let me go like this. Now that you guys understand that, right? I'm going to keep that like that. It'll still run. This will all run, no problem. Let me build it. I just deleted that extra, right? Because as soon as it gets to here, that's it. It's done, right? We're within our own block of code, so this will still run, no problem. Okay? No issues. It still runs through the code. This is its own blanket of code. Okay? Let me just show you something else here. Global. Okay? Can we see that global variable? And we should be able to see it throughout all of our code. I'm just going to go like this, global. See? If it comes up here in your list, that means it could be seen. It's visible. I'll just end it with a new line like this. And then I'm going to go like this. You guys, gals, it's important to understand the local and global variable thing because, yeah, I mean, you'll type code and stuff and you may put variables in weird spots and it may not return, it may not show up, and you might rack your brain, go, why isn't it? Well, these are the reasons. Okay, so I can print it here. And I could print it outside this. You see that, guys, gals? So remember, all this information is local to itself. Okay? This is all local to this scope. Okay? It cannot be seen outside this scope. But the global one can, because here it's way at the top here, guys, right? We're right at the top. So it can be seen throughout our whole, what's that term that they used? I should have wrote that down. The semicolon's called our terminator, semicolon. Let me just see. Where was I reading earlier? Oh, I was reading it somewhere online, wasn't I? Yeah. I should have wrote down that word. That's okay. The word that I used for our main CPP file, it had a term, but I can't remember it offhand. Let me see if I can find it in history. When we're looking up static. Okay. Hold up. I want to see if I can find it. It was on the internet. I searched it. Was it in here? Maybe. Still not finding it. I know I said it during this stream. I know I said it. It's just part of the theory, guys. It's not that critical, but... Translation unit. There it is. That's what I was looking for. Source CPP. So main CPP, also known as translation unit. Okay, there. That's the word I was looking for. It should be our word of the day, but it's not that important. Okay, that's what I wanted to use, right? So global can be seen throughout this translation unit. That's why I wanted to bring it up, right? If I use the word translation unit, you might have been like, what is he talking about? The translation unit is referring to our CPP file, okay? It's global. Again, it could be seen inside this block of code, and it could be seen outside this block of code. And I could run it and print it. No issues, right? I should actually start teaching my brain this a little bit, right? If a variable is ghosted, that means there's a problem, right? Both my variables, same color. You can see the difference in the variable color. I have my own theme here set up, and I love it. And so right here, that's the theme color I'm using for global variables. The colors are the same. It's not ghosted. That means everything's running and working good. Let's go. So I'm just going to go 12 and I don't know, 23. I should have had some enters in that, but you can see here, right? It's printed twice. This is the one that's inside our empty scope, and this is the one outside our empty scope. Okay, so let me put a \n here. And then maybe just type empty scope. I don't know. So that you can see, right? The difference. I have a space there, but that's okay. Area rectangle, yeah. Empty scope, global variable, and this is the one that's outside. Everything's still in the int main, but again, that's the difference, okay? So that's kind of a breakdown on local and global variables. You have a better understanding. And that was silly me. I had a kind of a silly moment. Again, I have Minecraft cobwebs in my brain today, I think. Need more coffee. More coffee, nurse! Coffee! Don't forget to buy me a coffee, guys. Getting low in the coffee funds. Things are going to get worse if I don't have coffee. I'm telling you. Speaking of coffee, let's have some. Whew! All right, that was a lot of good information, actually. We went kind of from functions to talking about translation units to talking about local and global variables. Lots of different things we learned. And you can learn a lot more just simply by adding in some empty scope brackets. Create an empty scope within your main, right? You could do this. And you can instantly see how local and global variables work. It's pretty awesome. Again, as soon as I take these out and put them up here, right? Now they've become kind of global variables inside our int main, if that makes sense, right? The point is these variables can now be seen. Well, obviously they can be seen inside our empty scope because everything runs line by line. And again, it's above our scope, so that's why it can be seen, right? That's what we want. And then if I actually go like this, like I was trying to show you earlier, you can see it can be seen because it's outside this blanket. All right, let's go. Silly me. All right, let's continue. Yeah, that was some key information. It was like the light bulb moment clicked on as soon as I read that sentence. Okay. Variables you declare within the body of the function are called local because they exist only locally within the function itself, right? It's the same thing with a function. I could create a variable inside the function, right? Function variable, right, equals, right? I could do that. So the point is this function is local. It can only be seen within this function. It can't be seen anywhere else, right? And this is actually useless here. Well, as a matter of fact, I could use it by going like this, right? Maybe I had a constant or something, right? I can use it in this sense, right? But again, so here this is a literal constant and this is a symbolic constant, right? I created a new variable. It's inside our function. And again, it can only be seen within the function because, well, it's inside this scope, right? Understanding scope is kind of important. And then you'll have a better understanding, of all the magic that happens under the hood. Again, once we get to the end of int main, that's the end of program. That's it. Everything is kind of like, well, if we're talking about stack memory or stack variables, it just gets cleared. It's removed automatically for us. Deleted. Bye-bye. Okay? That memory has to be freed up for use for other resources. Again, the memory, your RAM, is being utilized by, look how many programs I got up. I've got a lot of different things up and running. Programs for my computer itself, for my graphics card. All those use resources and memory, guys. Same thing with Chrome. It's using some of the temporary memory too. And you only have so much memory, right? I've got 32 gigs, I believe, total, if I recall, which is a lot. But again, you can fill it up. Bits and bytes. All right, let's see. Okay, local variables. Global variables have global scope and are available anywhere within your program. Okay, just like I was showing you, right? Okay. I know I cleaned things up. I'm just going to undo, but I wanted to kind of keep that global there so you can see that. And I removed that by accident. This could be like a multiplier. I could call it a multiplier. For example, it could be multiplier value. It could be anything. It could be, I don't know. Why am I doing that? Equals, I don't know. Let's say you wanted to multiply everything by 2, for example, right? For whatever reason. And I could add in my multiplier value if I wanted to. Just again, the world's your oyster. It's your function. You create it how you want to create it. You just got to learn the syntax. You got to learn all the local global stuff. You got to learn all the theory. You have to learn all the syntax and semantics. And once you get all that, then the world's your oyster. You can start creating your own stuff. Right? That's a great thing about coding. You actually, get to utilize your brain. I love people that know how to use their brain. talking about the ones that think independently and think for themselves. That's who I'm talking about. You know, the real free thinkers. Okay. Local variables. Not only can you pass in variables to the function, but you also can declare variables within the body of the function. Variables you declare within the body of the function are called local because they exist only locally within the function itself. When the function returns, the local variables are no longer available. They are marked for destruction by the compiler. Okay, LIFO. That's the LIFO process. Okay, and that's what I just read there is basically what they're talking about. Is that there gets bye-byed. Well, they pretty much all do, but there you go, right? Local variables are defined the same as any other variables. The parameters passed into the function are also considered local variables and can be used exactly as if they had been defined within the body of the function. Okay, so they said the parameters passed into the function are also considered local variables. Okay, a little extra theory and knowledge, guys. Doesn't hurt to know. Lots to take in. There's a lot. The great thing about coding, you're always learning. Doesn't matter how long you're doing it for. There's always something. And technology and everything's changing and advancing, and code behind gets updated or changed, or new methods are created, and you got to kind of keep current with things, right? There's always something new going on and something being made or created that makes our lives easier as well. All right. Do I create a float function? Because you can create a float function as well. I'm just going to delete this one that we created. This one's going to be takes in one parameter. It's telling me already that it can't be seen, right, or found, right? And the reason that came up is because of this here. Okay? And then I'm going to delete all this. I could get rid of the scope, or I could keep the scope. It doesn't really matter. Okay? And get rid of our variables. And kind of start clean here. Control-Shift B. Did I need to... Let me just see. Where's that again? I had an extra space there I didn't want. Okay. All right. Let's create a float function because you can. There's other data types, right, guys? Here, right? We have other data types. You can create a float function, a double function. Remember, float and double are floating points, right? Is that what they're called? Floating points? Not whole numbers. They're not whole numbers. All right, let's continue. So it's simple. So we'll kind of declare. So first step, declare. Again, I could go down here and just do my definition. The order of 1, 2 doesn't matter. Okay, you just got to remember. So if I create it down here, the program's not going to see it, right? This is part of the local global thing. If I forget to declare it, the program's not going to know about it. You have to make it global in the sense. So what are we doing? We're going to do temp converter. Okay, it's going to take in one parameter, being a float. I always match my data, my types, my return types. with my variable types or data types. That's what I do. We'll just call it temp var, whatever you want to call it. Or you could call it temp var. Temp var. Okay, you'll see what I'm doing here shortly. Okay, so I'm doing my definition. All definitions have a scope. Inside, we're going to create a temporary variable. Yes, we are. So you could do this inline, or you could do it like this. It doesn't matter. So we need kind of a right. Okay, temp and Celsius, right? This one's going to be, so I should initialize it. So I'm creating a variable inside, and then that's going to take a formula. Okay, and the formula is, we're going to use what I call bracket organization. Okay, that's what these ones here are. These ones here, they're for organizing. These brackets here are for, you know, whatever we want to put inside. They're for our parameters, for our arguments. Okay, but here we're actually creating a formula because you need, it's bedmass, pedmass stuff, and I recommend that you use brackets, especially this formula that we're using is the temperature formula, and it's a little bit unique, right? So we want the temperature in Fahrenheit to be calculated first before we multiply it by 5, and then everything, let me just get the separation here. Okay, what? 1, 2, and there should be one here. Hold up. Oh yeah, okay. And then all of it gets divided by 9. There, okay? That's what's happening. Okay? This is all part of the organization, right? All of this is the numerator. Okay, and then it's a return type. I can make this static. I'll just remember to do it at the top. You don't need to put static here in our definition. That's the point. So I know the program wants me to make it static. I could show you here, right? But again, you don't need to declare static in your definition. We need to tell the program ahead of time in our function prototype, hey, function, or hey, program, this is a static. Okay, so, and then this is our return type is float. So we're returning our temporary value, right? So when I said earlier we could do everything inline, you could. I could take all of this, instead of going like this, what do I mean by inline? That's what I mean. Okay, but this variable isn't initialized either, right? Technically speaking, all we did was right-hand side it with the formula. So it's however you want to do it, okay? Again, this is a simple little function. Again, functions, you don't want to do lots, right? You don't want 100 lines of code in a function, okay? Don't go wild with your functions. Keep your functions simple, clean, easy to read. Okay, so now I'm going to take this, Now we have to give the program a heads up. I could build this, it's gonna error, right? I should get an error somewhere. No? You're not gonna yell at me? If I ran it, it might, well, mind you, if I call it, it might actually, that might be the point. So let me just see. I gotta figure this out so you can see. I'm trying to break it. Okay, it's gonna take a value which I haven't put in yet. I haven't actually created any variables, so I need a float result for, it's going to return Celsius. Okay, there. Okay, and just like we were doing before, it's going to equal to that, right? It's all the same thing, guys, what I explained earlier. Remember, our float function takes in an argument. Okay, this is the parameter. We need to put in an argument. So I could hard code a value for now. Fahrenheit. Let's say we wanted to know what 80 was. Okay, so I'm going to go, actually it's an int, but it should make it a float. And it's going to be FAHR value. I'm just going to make it to 80.0F. Okay. And normally I go like this. Okay. That's going to be what. That's going to be our argument. Oh, why do I keep doing that? There. Okay. So there we go. There's our argument. Boom. Okay. That value. I'm using symbolic constants, guys and gals. Okay, that's the proper way. Okay, it takes in a float. Yes, these are floats. They all match. If I run this, now I should hopefully get some errors. I should get the program yelling at me. Please yell at me. There we go. It did it. Finally did it. Okay, so this is the program going, hey, your temp converter identifier not found. It's kind of hard to understand what it's saying there. This is helping you guys understand, because you're going to have these little, they're not bugs, but you're going to have these little silly mistakes, right? You're going to have all the little silly things happen when you're coding, and you're gonna have to try to figure it out, right? You could click this, it'll give you bring up an internet page. Microsoft's great for that. Each of these is kind of a unique, they figure out all the things that, all the silly things people can do, and they give you some support in how to solve the problem. So I know just from experience, right? That's why I say 1, 2, 3, right? So if you see this, we're just missing our first step. We have to tell our compiler, hey compiler, we've created a method or a function. It's in this program. This is now global, right? If you think about it, right? Now it's a global thing, right? We have to give the program a heads up and say, hey program, we got a function somewhere in here. You're gonna have to find it. First you're gonna have to look for its call, right? Look for its call, and that's right here. Essentially, this is the calling part, and we're storing it. Remember, it's a return type. We have to store it somewhere. That's why we create the extra variable, because that calculation has to be put somewhere. Right hand side gets stored into left hand side. Okay. And then let's return it to the console. So I'm gonna go, I don't know, because we're putting in, hold up. Yeah, get canceled. Okay. All right, carrying on. So we're converting Fahrenheit to Celsius essentially. That's what we're doing here. Okay, created our own little program. Celsius. I think that's how it's spelled. I don't spell Celsius much. I just go degree C. Celsius. Well, look at me. I know how to spell Celsius. That's amazing. Okay. And there we go. Return our result. Return the variable. That's holding that value. Whoops, my bad. And then I'm just going to do this because it's kind of easier to do. And there we go. So these are all, they're local to the main, but they're global in the sense throughout the main. Okay? If that makes sense. All right, that's why this variable can be seen here because this variable is above, right? We could put it inside. We don't really need it outside. They usually say, keep your variables within your scope for the most part, unless you need it globally, right? But yeah, this is probably the best way to do it. Okay. All right, good. Let's build it and run it. So now we hard-coded our value here, right? Note how you write your variables or your literal constants for floats. Ends with an F. Okay, there we go. 24 degrees. And I could have actually... What? Oh, I'm reading the wrong one. 26.67 repeating. And because it's a float, we're returning a float. A floating decimal, right? There you go. We just broke free from whole numbers, guys. Broke free from whole numbers. Look at us. I'm going to change this up. And I wonder if I could do that. Alt 0176, is it? Yeah, it is. Let's see if it actually prints it to the screen. And then I'm just going to put a new line there. Let's see. Sometimes the program doesn't like these unique characters. Like squared, for example, and such. It doesn't like those. Yeah, see? It broke in the console. I can see it here in code, but yeah, it doesn't like that. It doesn't like them special. They're, I don't know what it falls under, UTC, some other... Oh, I probably have to cast it to like int 32 or whatever, something to that effect. I never really focused on that stuff too much. It's like whatevs. But you could do that sort of thing, right? So we'll just go degrees C, good enough. Okay, I think it's, what does it fall under? Degrees symbol falls under, I don't know even how to explain it. What is not on keyboard, UTC maybe? UTC 03, is that what it is? I don't know, I'm guessing here. The degree symbol, not an indicator for UTC. It denotes a unit of measurement. I should have wrote like computer or something. The degree sign has the Unicode code point. Okay, I'm just gonna go like this. Unicode. Okay, just wanted to explain that, right? There. U plus 00 B0. Unicode. Alright. Now, I don't know, like, I know it as Alt 0176. Alt plus 0176. That's the keyboard shortcut, if I'm right. This is all stuff I used when I was like drafting and stuff, so I remember all these things because you worked with degrees a lot, right? So I learned all the little alt shortcuts. Not all of them, quite a few of them, I guess. Squared, cubed, those sort of ones. But there's this, I'm just trying to think of it. We have different, I feel like, I don't mean to go on a tangent here, guys. I want to see if I can find, do I have notes on that maybe? If I don't find it, I'll just move forward. Something to do with strings, maybe. Yeah, there we go. This sort of stuff. I found it. I'm not going to get into it, but there's this... Because you have all these different characters, right? Your common keyboard characters fall under the ASCII table, right? I haven't really got into that yet. I didn't mean to even get on topic now about this stuff. But you have different types of characters. Some characters don't fall under the keyboard. And you have all these weird characters. Right? Again, here's the table. This is one of those things... right here, right? I've been meaning to get into this eventually. I didn't mean to get into it now. But every character on your keyboard is associated with it's a decimal hex value, hex number. This is the link, right? So anytime you press a key on your keyboard, you're not pressing G, you're actually pressing for this value, this decimal value. Essentially, in that sense, right? And then you got all these extended characters, get all these weird characters, right? A lot of times you'll see this if you're going out of bounds of memory and such, but that's another long story. That can happen with arrays if you don't know what you're doing. But you'll see characters like this spit out into the console. This all reminds me of Call of Duty 4 Modern Warfare PC days, slapping Russians in shipment servers. Good times, good times. But yeah, the only ones we really care about are these main ones right here, our keyboard ones. And then the null one, which is kind of a C style, but null is 0. Okay? That's getting into characters and strings, so stay tuned for that. I have to finish up, guys and gals. I figured I'd throw that kind of in. Thank you for watching the whole stream. If you've been here, I apologize if I didn't get through this any faster. Hopefully you learned a lot. That was kind of the goal. Again, this is a lecture course outline that we're following, guys and gals. I'll go kind of jump around a little bit, but I want to explain all the little nuances and the important things I think that you guys need to know. And also, when we actually get into that area of the course outline, you'll be like, yeah, I know that stuff. Yeah, I know that stuff, right? It's going to get easier, right? That's the goal. Get you familiar with the terms and the theory ahead of time, and it'll get easier, guys. Okay? Johnny Whiskey Tango's sharp coding. Doing my best to make it easy for you over here. Let me just make this. We didn't get too far in the course today, but that's okay. I think we went through a lot. Johnny Whiskey Tango Sharp Coding, I appreciate you. Thank you for following, watching. I'm going to leave it at that. Hopefully tomorrow's stream goes a little bit better. I got to stick my head into a cold shower or something cold, maybe a block of, maybe stick it in the freezer for half an hour. I don't know. Anyways, that is it, guys and gals. Appreciate you. I'll see you in the next live stream. Take care for now, whoever you are, wherever you are. Have an awesome rest of your day. That is it. Johnny says take care and peace out, guys. Peace.
Baby, I don't understand this. You change